transistor logic. Some of you are designing your gates projects in past transistor logic. Who all are doing it in PTL? Put a +5 in the chat window. No one? Huh? No one is designing using PTL, at least of the few people who are in class today. Why is the class strength so low today? Any ideas? Midsem ended last week. So we can probably have a surprise quiz in the class sometime. Let us see. So
maybe there is some document verification today for some people.
is it the case for some of you?
Some are there.
So some of you are expected to be on campus today. Am I right? Is that the expectation? Yes, because even on Wednesday the class strength was low. Okay, no problems. So a past transistor logic says that in the static CMOS and in this ratioed logic also, we had these PMOSs and we had these constraints of how big the PMOS should be, what should be the ratio of the PMOS stack and the NMOS stack and so on. We had all these things. The question comes, can I design only with NMOS transistors? No PMOS at all? Especially, in 1970s and 80s, PMOSs were not even there. So everything had to be designed with an NMOS logic. So what do I do if I have to design with NMOS logic? Because if I have only NMOS logic, then there is no VDD to ground connection also. So there will be no static power consumption. And that is where we talk about past transistor logic, where NMOSs are used as switches. NMOSs are used as switches, you may say. So what do? You make a switch network and then you simply buffer the output. Okay. So in this kind of a network, an AND gate would be designed simply like this. Are you able to see this? That this is AND functionality? Can you work it out for yourself? Hello? Is this okay?
Yes.
Huh? AND functionality is clear. Now the beauty of past transistor logic is that you can have AND functionality also, and you can have NAND functionality also. So you no longer are limited to inverted output. Suppose in a static CMOS or even pseudo CMOS, if you wanted a AND gate to be implemented, you will first implement a NAND gate, and then you will implement, then you will add an inverter. Over here, that is not required at all. Just two NMOSs, and you have a AND functionality. Then what is the challenge? The challenge, so as we said, you put something and then at the output you put a buffer. The challenge is that now this in, let us say this in goes from 0 to 1. If in goes from 0 to 1, this NMOS turns on, it charges up Vx and output goes to 0. So you get the output as 0. But what about X? X is at what value? What will be the value that X will be at?
So when in is going to 1.
minus VT, sir.
Yeah, VDD minus VT.
VDD minus VT. So what happens to this, the current of this inverter now? What happens to the current of this inverter now?
Sir, what do you mean by current exactly, sir? Output current, sir?
What do you mean by current of an inverter?
Sir, load which it supplies, the current to the load which it's
Only
supplies.
that? Do you mean only that when you talk of current?
Current from the VDD, sir.
Yeah. So what happens to the current from VDD over here? That is what my question is.
So sub-threshold starts from PMOS and something more maybe.
Now the PMOS is not fully off.
Yes.
So the PMOS current or the subthreshold current or the static current that will flow will not be zero.
No, I mean, can you? I'm not going to get this point. Why the inverter would be not?
You tell me. I have this inverter. The input is this. So what is happening? This is VDD minus VT. So you're just at the boundary of threshold voltage for the PMOS. PMOS is off, but there is still static current, a significant amount of static current happening. NMOS is fully on, that you are able to see.
Yes.
So NMOS is fully on, PMOS is off, but not fully off. So there is a significant amount of static current coming from here, which would be sunk here. Now the ratio of this just off PMOS, resistance of just off PMOS and the resistance of a fully on NMOS, that ratio is such that you're still getting an almost zero at the output. That is a different thing. But do you realize that there will be that will be a very high subthreshold current flowing over here? Are you able to see that?
Sir, how can we say that my NMOS is fully on, sir?
You tell me.
Sir, as my input is not when touching the one position,
When
sir.
does NMOS enter into saturation region?
When my okay, VDS should be greater than VGS minus VT, sir.
Is it greater than VGS minus VT?
Sir,
Is it greater than VGS? What is the VT that you see in this photo?
VT is the between thing, sir. X2 output between gap.
What is that value?
That's VT, sir.
What is the value? There is a x-axis is labeled. It is not that.
One,
almost
sir.
1.
I think, yeah.
So let us say 1.
Yes, sir.
So what is VGS minus VT then? When x is equal to 1.5?
X equal to 1.5. It's 0.5, sir.
So VGS minus VT is greater than 0?
Okay, okay, sir. Yeah, yes, sir. Yeah.
It is in saturation?
Yes, sir. Yes. Sir.
See, you have to. Okay, so this is one thing that I'm observing in the class. You're not using your, the logic that has already been taught to you earlier to arrive at a analysis, to do some analysis. You're waiting for either me to analyze it for you or someone else to analyze it for you. This is not right. Please use your knowledge that already you have to quickly do this mental estimation. Na? I have no problem in helping you. But the problem is, if you continuously look at me, when will you become independent? You're more than halfway through the class, through the course. At this point, this value that is this greater than VGS minus VT, should I be helping you solve this?
No, sir.
So please, at least try to become independent. Again, you make mistakes, you ask questions, no problems. Unless you make mistakes, how will you learn? I have no problems with you making mistakes. But at least this analysis you do and then say, sir, मुझे तो ये 0.5 मेरे को तो ये off दिख रहा है. Why are you saying it is on? Instead of saying why are you saying it is on, you tell me why do you think it is off, and then we will review again. But you ask me to arrive it for you. That is not right. When will you become independent? So ask as many questions, no problems. Validate as many doubts, clarify as many doubts. But this is not a doubt. This is something you not even tried to solve something and you are asking a question. This is not right. Are you able to see this?
Yes.
So if we have NMOS only logic, while we started, now you remember when we started the PTL, we said there will be no static currents. You remember this? On that slide, we had written no static current. But what did we just see? There is all of a sudden all the static current that is happening there. Are you able to see this? So we started PTL with no static current hypothesis, but we just realized there is going to be static current in PTL also. So what to do now?
So like I was thinking, like instead of like we are implementing our combinational logic using PTL and then we are using this inverter for the buffer. But if we, okay, but can't we implement this inverter also like in PTL logic itself? Like if we put this simple NMOS and then connect the X to that gate also like.
Okay, how will you take it to VDD then? Output to VDD then?
I mean, like, so when that X is on, so VDD will be basically we will reach that.
Try. Let us try. Why not? No, this is a good question because this is still exploratory. This is a good question. No problems in handling this question. Let us see. इसी example में let us see what happens when I want to make inverter through a pass gate. So what are we saying? We are saying for an inverter, you would put the input over here, or no? For an inverter, then what you would need to do, you would need to say that either I will put input over here. So input is 1, output should be 0, and I will put 0 over here. It got stuck. Let me go to whiteboard. I'm able to do something. Not able to write. I'm not able to write on the screen. So what are we saying? We are saying that there is a input VDD. Now over here it was a Vx, and we now say that this Vx will put somewhere so that I get the inversion there. I get a full VDD to ground swing there. That is the purpose of putting an inverter. Are you with me on this? Why do we put an inverter in the first place? Because I want a full 0 to VDD swing.
Yes, sir.
Huh? Now tell me how to design a PTL based inverter. I can take this Vx to a gate of an NMOS.
Yes.
And I will store a 0 over here. So my output will go to 0 over like this. But when the output has to go to 1, how will I put this NMOS? What configuration should I use?
Yeah, then we have to put the VDD, but then also it will be reduced. Okay.
Okay, you're saying VDD. So what is the benefit now?
But then
So if I put VDD over here, what happens now? The gate is at Vx.
Yes, sir.
What will I get over here?
VDD minus.
So 2 threshold dropout will be.
Yes.
Yeah.
So can you do it?
So one was threshold drop because the earlier and this, okay, yeah, two threshold drop.
Are you able to see this?
So why two is coming exactly?
So one VT drop because of this.
Yes, sir. Yeah.
One VT drop had already happened here.
Yeah.
है ना?
Yeah, inverter we had to implement it static.
Yes. So अब क्या करें? So you see, this doesn't work. You will have to use an inverter there.
Yeah, yes, sir.